the project. Just so you guys are aware, we have to on the next 2 weeks we will have to make a call on whether we give you guys more time to work on the first project for until the end, of course, or we are happy with your solutions and we move to a second project for the last of the course. So if you guys can do that last push to make sure that we can complete this project on these next 2 weeks, that would be really nice. So you guys can have a play with the second one, which will be all serverless and all different stuff again. But there's no point of moving to a second one if we don't have a fully solution deployed and working, and because we still have a lot to learn on this subject. Just wanted to say that if you can get that last push to get everything working, would be nice. Cool, let's jump into the class. Can you see my screen?
Yep.
Yeah. Okay.
So this first bit of the class will be covering a few AWS services that we already mentioned around, and you guys may already did exercise with it and you're using for your project, like S3, RDS, CloudWatch. But as we can't show you everything on the same class, on the first class, that can happen. Like you will get exposed to the service before the class, so there's not much to. So I'm not gonna cover like lots of demos and stuff. I'm just gonna try to cover some more features about those services that can be useful for you, and then we'll try to leave more time for Kiku to play with CI/CD and actions, which will be really helpful for the final stage of your projects. So S3, as you guys know, it's the storage service for AWS. It's high scalable, durable, like the normal S3. If you just upload a file to S3, it has like 11 nines of durability. So it pretty much means that you won't lose your data for any reason. On AWS documentation says that it's a very low cost, but that can get very expensive as well. I'm pretty sure we discussed that on the first class. So storage on the cloud is in an enterprise level. It's not cheap, but essentially it's probably going to be cheaper than running on Google Drive or something like that. Main use case for S3 service is storing data. So it is really useful for data lakes, data analytics, like where you need close to infinite amount of data, like terabytes, petabytes. It's a really good use for storing, just essentially storing data. You could use to host entire websites on it. It needs to be static. So like if it's a .NET or Java, it won't work. But if it's HTML, JavaScript, CSS, like static websites, it is a really good solution for that. We actually ran the DevOps Academy website from an S3 bucket that costs nothing. It's literally costs nothing to run there. And for backup and archiving as well. So when you upload a file to S3, I'll cover this in a moment. You have many options of what will be the type of your object. The normal one, which is called the standard, is this one that is not really cheap, like thinking on an enterprise level. But S3 has another one that is called Glacier, which is you can use it for archival, and then it gets really cheap. But then it has some special characteristics. So it can be really good for backup and archiving, as it can get cheap depending on the type of your objects. Some concepts about S3. The buckets itself, it's the container where you're going to store your objects. As you guys know, it's a global service on AWS, and it must have a unique name across all accounts, all regions, everything. So it's a unique name across the whole AWS service. all the files that you upload to S3, they have a URL that you can access the file, but it doesn't necessarily mean that it is accessible. You control that access if it will be public or not, but all the objects there also have a HTTP URL to it, because essentially it's a S3, it's a database. Now, one important thing is that S3, it's not a physical hierarchy. Like as much as you can see, like it looks like folders and files when you are browsing around S3. It's actually not folders. It is. So if you have a file that is called, I had one example here. Where is it? Oh, here. So if I have a file puppy.jpg and it's under the folder photos, this is not actually a folder. This is the name of my object. It's the key of my object. So it's just the folders are just a nice way of organizing my files inside my bucket. But you can't think as you can think as a folder, but it's not essential. So you have the objects, which is the files that you host on S3. And those files have lots of you can store lots of metadata on it. For example, the content type, you can add tags to the object and have many other information as a metadata for each object that is on S3. Some important things around the object itself is that it can go from 0 bytes to 5 terabytes each file. Like S3 is close to infinite space, so you could possibly store anything that you want, but the maximum size of one single object is 5 terabytes. But for a single put, so when you're writing your application, or if you do an upload on the S3 console, that is a single put of a file, the maximum is 5 gigabytes. So if you need to make an upload of something that is 10 gigabytes, you will have to do a part upload. A part upload. S3 has an API that does that for you, so you don't need to create one application that will break your file in smaller parts and upload those. If you use a different API key, what we'll do is we'll break down the file for you and we'll upload part per part. Using 5 gigabytes. I'm pretty sure when you do the multi-part upload, if you have a 10 gig files, it won't do like just two parts. It will break down in smaller chunks of data to make it faster and guarantees that you don't lose data transferring. So the keys that I mentioned, they are unique for the bucket. On that folder structure, I won't be able to have 2 photos puppy JPEG on a single bucket. They are unique. And you can have versionings on your bucket. This is actually an option that you can enable when you're creating a bucket, or even after you create a bucket. Sorry, it's an option that you can enable or not. When you enable versioning on your bucket, every time that you replace or you delete or you change that key, that object, it will create a history and will keep, like Git, will keep all the history of that same file. Talking about storage classes for S3, as I said, the first one standard. So if you don't pick anything, the storage class will be standard. It's the most expensive one. It's the way that you will pay more for S3. It has the 11 nines for durability. Availability is still quite good for nines. It's cross all the AZs within a region. I think it's even multi-region, but I'm not too sure of that. No, it's so AZs. So at least 3 AZs, your data is backed up by AWS. And when you are executing API calls to upload files to a bucket, you can actually choose what will be the storage class for that object. This is something that you need to input, otherwise we'll pick as a standard. So I'm not going to go through all the storage classes. The most used ones are standard and archive and glacier, which is the for archival purpose. when you convert your file to Glacier, still has the same 11.9s and the same availability. The catch here, why it's cheap, it's because when you need the file back, it might take some time to retrieve. So AWS will move your data to, I don't know, some backup place that is not real time available. And then when you make a request on the console, it can range from a few minutes to a few hours, depending on if you want to pay more to retrieve that file, it can be in less than 5 minutes and you will have access to the file. If you don't want to pay, like you don't care with the time that it's going to take to get a file, you just want to have your backup back, it's not really expensive, and then it might take a few hours to be available, and then you just get a notification that your files are available, and then you can download them. So this for companies that need to keep files for 5-10 years, you just move everything to Glacier. So S3 also has something called life cycle policies. You can have life cycles on your buckets that will, for example, you make an upload of a document, a contract, and then you create a life cycle to after 6 months of being there, it moves automatically to Glacier. So you don't need to keep track of the files and keep moving. And then if once you need that contract back, you just go and make a Glacier retrieval. You start the Glacier retrieval process. If you need straight away, you can pay more. It will be available in a few minutes. There is it's not new, but it's one of the, like, it's been around a long time ago. The intelligent storage class, which I don't even think that is here. This one, which is AWS. If you enable this one, AWS will try to keep moving your files to the best class storage based on your needs. So if it understands that your file not being used, you're not accessing, you're not downloading that file, it might move to Glacier, or it might move to, if it's a file that you don't, for example, you want to save this file on S3, but you don't care if you lose it, because you can get get it back from somewhere else. So there's this infrequent access. Yeah, I'm pretty sure this one. This is like half price cost, but it's not very, it loses 1/9 of availability here. So essentially saying that it can happen that I need to download this file from S3 and S3 is down and I can't download it. To be honest, been using AWS for 10 years and never seen an outage on S3. It's a very stable service. That's it. I just want to show a quick demo on S3. You guys have done some exercise like uploading files from EC2, which involves putting a role on the instance profile on the EC2, which is already very like advanced use of S3. So I just want to show you the website hosting part. So console S3. You see that I have a few buckets. This is my personal account. As I told you, we have DevOps Academy bucket here. It's running, it costs nothing. I'm gonna create a new one, DevOps Academy test. Not gonna configure anything here, just hit create. I'll grab my bucket. Don't have any objects. I'm gonna make an upload of a file. Just this index guy here. So I have one file on my bucket. If I click here, I'll see some options. As I mentioned before, the object URL. So I always have a HTTP URL for bucket objects. That's by default. So this is public. Like it goes to s3-AWS region.amazonaws.com. So it's a public URL. Let's see if that works. So I'll try to open this guy, and I got access denied. So that was what I was expecting, right? I create a private, like a bucket just for myself, upload something. I don't want people to access. So that's fine. If I want to enable people to access this file here, first thing that I need to do is go to permissions on block public access. By default, every time that you create a bucket, it comes with block all public access. If you are doing with Terraform, that doesn't come by default. You need to, this is actually a resource that you need to add to your bucket to block the public access. But all those configurations here are just to block people to enable access. So it doesn't mean that if I just click here, block all public access, need to confirm that I want that. And so as per what the UI is telling me, it was blocking all public access and now it's off, right? So let's try that again. It's still not working. So it doesn't mean that now it's open. It's just that those things here are kind of a guardrails. So when they are enabled, if you try to go into your bucket policy and enable public access, S3 won't allow you to do it. So it will block you. It will say, look, you are protected to not allow public people to access your stuff. So in enterprise, it's very common to have this option here enabled by default via SCPs, which is a global thing. And it won't allow you to remove this one, to put it off. And then you will never be able to open your bucket to public access. It's just a way of enforcing that. So to actually make the objects public, I need to go to bucket policy, and I need to fill up some, I need to create my policy to enable people to. If you don't know how to write a policy, there is a very good policy generator here that you can click. You can change the policy that you need is a S3 bucket. I want to enable everyone. I could limit to a AWS account or a user or role, but I'm gonna pick everyone. Amazon S3, all actions. I could limit to get objects, so allowing people to get objects from my bucket, but not putting objects in my bucket. And everything here as well. So will be everything under my buckets. I click add statement. I can create more conditions, but that one's fine for me. Generate my policy, and that's what I need to use. So this one is not quite right. The principal here needs to be the ARN of my bucket. And I need to tell that / everything inside my bucket, I am allowing to do an S3 and any actions on S3. That's essentially what the policy is doing. When I hit save, it's gonna, oops, what is wrong here? Oh no. What is wrong with my policy? That wasn't expected.
Here's the ID.
And resource action principal. It's not principal, sorry. It's resource. Principal is AWS account, users, roles. So when you have a policy on your bucket that makes your objects public, you got this little warning here saying your bucket has public access, like you know what you're doing, like make sure that this is intended. So if I try to access this guy here now, it works. So essentially I can access my file. Quick test that I want to do here is, instead of allowing everything from my bucket, I will do index.html. So essentially I'm saying that the index.html is public, but anything else I don't want to be public. Now if I go here, do another upload, and this PNG file here is fine. I'll grab this guy and we'll click on the object URL again. try to access denied, which was intended, right? You guys have any questions here? Just wanted to show you a bit of permissioning on different files. Sure you have run into that before. Some other options on S3. So versioning, just mentioning, if you enable that, every time that you modify a file on S3, we'll start having versionings of that file. Be aware that that will add up on the cost. So if you have a gigabyte file and you change it 10 times, you have 10 times that file available. Server access logging, this one here, you can point to all the modifications on your bucket to be logged into another bucket or on the bucket itself. I didn't know that I could use the bucket itself maybe 2 weeks ago, but I always created a new bucket to serve as logs for the access of this bucket, but you actually can use the same. Default encryption, this one will be very common to use. So normally in enterprise, it's a requirement that you always have your data encrypted on your buckets. If you click here, you have two options. The three options, two options of encryption. None. This AS256, it's a key managed by AWS and S3 itself. You don't need to do anything around it. It will do all the management for you, rotation of the key and everything. And the KMS one is to use the KMS service that I will mention very soon about it. And then you can select a key. Again, you can use KMS and use the AWS provided S3 key, or you can provide your own key. It is saying here that, look, if you use encryption, you have public files available. If you use encryption, you will have to provide the encryption key when you're trying to access the files. Because essentially, if the file is encrypted, if you try to download it, you have to provide the key to decrypt it. Otherwise, it won't work. You normally, if you're using S3 to host a website, you won't add any encryption to it. And those are more advanced ones. Let's do just a quick test here.
May I ask you a quick question?
Sure, man.
The server access logging is just to log the, like you're saying, the access request. So someone that is trying to access the files in the bucket, or
yes.
Okay, so it's not possible to log, for example, file changes, these sort of things.
I'm pretty sure not. I think it's like a web server access request.
Okay.
Yeah, if you need that, you have the object level logging, which will provide information about changes in the files and all the put, pull, or any interaction with the S3.
CloudTrail would be the best service for that. On CloudTrail, you'll be able to see which role did a put object on what object.
Thank you.
Static website. I can just use this bucket to host a website. You can type here the name of all of my index. And as you guys can see, the endpoint for that website will be, it's here. It's HTTP by default. Can save. And then if I click this link, it should work as a website now. So the difference here that you guys can see, the other URL that I accessed before, it has the object key here because I was accessing the bucket plus the object key. Wasn't like as a static website. Now as it is a static website, it doesn't show me the index HTML anymore. It's just my main domain. If I go back to my buckets, another thing that you can do, for example, here, devopsacademy.com.au, consider I have one without a www and another one with www. If I go on this one, there's nothing on the bucket. If I go to management, properties, static website, it is being used just as redirect request. And sending everything that goes to www sends to the devopsacademy.com.au. And then you can use another service called CloudFront. I'm not 100% sure that we will cover that on the serverless class. I think so. That then you can serve the files on S3 through the CDN, to the delivery content network.
Can't you just host a DNS, use the DNS instead of creating like another bucket?
Yeah, you can. You can, but just buckets that doesn't have any cost for a bucket. You just pay for whatever it's hosted on the bucket. So you're not paying for anything to have this one here. This is just a way, you know how on web servers you do redirects as well? You need to do a virtual instance to do a redirect. This is essentially what you're doing.
Yeah.
Cool, that's it. Any questions on S3? That's pretty much 90% of what you're gonna use S3 on when working with AWS.
Kyle, if you want to access any file, you need to use that function AWS press sign to put the object available.
Sorry, can you repeat your question again?
If you need to access any file on any bucket, I think made it available for everyone to click and access an image or.
Yep.
So you need to.
If you are not, if your bucket is not a website, you just want to share files with people, you can make the object public and share this object URL. It's not the safest way of doing. Other way of doing is, if it's for your same company or for yourself, you can actually have a role or a user with enough permissions, and then you can use the AWS CLI or the S3 CLI to download the file. And then you are essentially using AWS credentials to download the file. Then you don't need to make it public here on the bucket policy. But if you want to share with anyone, it needs to be, you need to make the object public and share the URL.
You can also have signed URLs, right? Now you can have something that will sign the URL and create a new link that will provide access to that file for a period of time, like 1 hour, 2 hours, something like that. So that's a good way as well to share some images or some documents that you have on S3 publicly with other people.
I can't show you because you can't generate self-signed URLs on the UI. You need to use the CLI, but essentially you just create a link that will expire in any time that you want. I forgot about that. And you actually can generate a self-signed URL for uploads as well. So if you want to give access to someone to just upload something on your bucket and in one go, you can send that.
Okay, thank you.
It's called pre-signed URLs, right? Totally.
I have a quick one for you, Kyle.
Sure.
Do you know any workaround to protect S3 static websites with user and password?
You want to protect the bucket itself with user?
No, the website. If I host a static website on S3 and if I want to protect it with a user and password, what would be a nice workaround? I know that there are ways to do that, but are you aware about any simple one?
I think you will need to implement on your application the control of the user and password. Then you could maybe use Cognito to control that for you, but that will be a part of the application. I don't think AWS offers anything for that.
Right. You can use the JavaScript SDK just to control the authentication using Cognito, as Kyle said. There's a service that's progressing very, very well with several new releases called AWS Amplify. It helps you building mobile applications or static applications like this, integrating with Cognito and other AWS services, having APIs in GraphQL, for example. And yeah, that's the main way to authenticate. It's a common pattern. So you use JavaScript SDK and Cognito.
Let me just grab I have a repository here if you guys want to play around. It is a bit old. It's 2 years old, so I think it can be reused still. But essentially use all serverless stuff. So this was just for playing around with S3, and as you said, I need some sort of authentication as well, and authorization. This is essentially a serverless thing. Sorry, it's a file sharing in a serverless way. So it uses pre-signed URLs and upload the files to S3. It will clean up S3 every day. So you know on enterprise that you always have the issue that how I can send these 20 gigabyte files to someone. And it's always a pain. And I need to do this just for 24 hours or 48 hours. And it's all serverless, so you pay just for what you use. It's on my GitHub project. I can send you to you guys later, but this was before Amplify, and Amplify and Shell will make this one here much easier. Cool. Very quick about RDS. You guys are using that one for your projects. It's the database managed service for AWS. It has the most common flavors in the market, like MySQL, Microsoft SQL, Oracle, Postgres. Being a managed service, you don't need to worry with patching, upgrading, backups, and those sorts of things. It's multi-AZ available by default. If you go with Aurora, for example, it is always back up to at least 3 availability zones by default. Important to mention, I think we touched this the other day, that Aurora is a compatible service with all those flavors of database. It doesn't necessarily mean that it's exactly the same. It is the AWS implementation of those services. They work in 90% of the case, but it sometimes on old database, old implementations that have lots of customizations on the user end, like what's called, forgot the name, the functions that you have on your database. When you have too much customization on the nodes,
Store procedures.
Store procedures. You most likely will run into issues if you want to run on Aurora. But if it's a new application, it's always recommended to go with Aurora. It's much cheaper. I think it can get up to 10 times cheaper. And it runs multi-AZ, has backups, and lots of things that you need to pay extra when doing with RDS.
Yeah, for Aurora, you can also have global tables,
Yep.
global database, which means that you can have the same database being accessible from 2 different regions. So it's pretty nice as well.
It also, Aurora is also compatible with IAM, so you can use roles to give permission to access the database. It's quite nice. Something that you don't have when you're doing with RDS traditional.
You have now. You're able to configure your database, even MySQL. I'm not sure about Oracle, but Postgres and MS SQL to use IAM roles to access some tables. So you're able to do that now.
Cool. Nice update. That's the problem with AWS. Use Leap, and there is something new. What else?
The serverless side of Aurora.
Yeah, Aurora serverless as well. It's quite nice. You pay for what you use. It's not much more expensive, but I think it's like 30-40% expensive, more expensive than running the normal one. But if we are doing exercise and those kind of things, like you don't pay anything if you're not using. It's always good to start with on the project, and then once you know how much you need, and then you start provisioning the size of your database. With RDS, you can have some scheduled maintenance window. So it means that the updates and patching from the AWS will run on predetermined times during the day. So you normally will try to put those into some time window that no one is working or less people is working, because it tends to have some degradation of the service, like it's some bit of slowness, and it depends on the size of your database as well. You could still run database on an EC2 instance. Highly don't recommend that. otherwise you have to manage everything by yourself. When we decide to move to the cloud, we are kind of accepting that new way of thinking and going as much as we can with managed services. And that's it. There's not much to talk about RDS itself, because that's essentially what the managed service is supposed to be like. It's to control everything for you, and you just need to manage your data and your tables and your... Any questions? The next one will be quite quick as well. I'm not gonna run a demo creating an RDS table, otherwise we'll have to wait 15, 20 minutes creating. KMS, mentioned before, so it's the key management services on AWS, again, managed service. So we expect that AWS will have some sort of availability for me. It is across all the 3 AZs, so it is a region available service. It can control key rotation for you in a few services. For example, if you have KMS linked on your S3 bucket, it can do the key rotation for you. A quick catch is that if you rotate the key, the files will only get the new, will only be encrypted with the new key once you update or upload a new file. And then AWS will do for you the change of the key that was used to encrypt the object. It can be very simple service, and it can get quite advanced when you are starting to bring your own key material. Key material will be like your private key, the private part of the key. So if you need to bring that to AWS to manage on your KMS and be available on your service, it can get complex. We don't need to cover that here. For the project itself, we expect you guys to encrypt as much as you can, but we are happy for you to use the keys that AWS provides for you. Most of the services that AWS are compatible with KMS, they already provide you a key by default, so you don't need to create yours. If you need to create a key, I think it's $15 per month or something like that. There is a cost, so don't need to create. And if you create a key on KMS, be aware that you won't be able to delete for at least 7 days. That is a protective measure, because imagine you have a key and you have 1 petabyte of data on S3 that is all encrypted with that key, and you delete it and you lose it. AWS won't be able to do anything for you because you delete the key. So they have this protective measure. If you try to delete a key, it will ask you, when do you want to delete? The minimum is 7 days and will be there pending deletion. So if an administrator, an admin can come back and stop that to happen. As it's an API command call to start the deletion of the request of deletion of a key, you could potentially use that to trigger notifications for people like, look, someone's trying to delete the key. Do you want that to happen? Something like that. We'll cover on the next topic, will be CloudWatch. When creating keys, you essentially have 2 types of keys that you can use, symmetric and asymmetric. The most common one being the symmetric one, which is the same key where we encrypt and decrypt. We have some quick example here to use Terraform to create an EBS volume. So having a key created on your account, kind of the same as S3, you need to edit the policy of the key and give access to users, roles, or AWS services to be able to use that key to encrypt or decrypt your data. And then this is an example of creating a EBS volume when, like for the EC2, when you attach an extra volume to your EC2 to use an encryption key to have your data encrypted at rest. So creating a volume, one of the options will be encryption, and then you can just choose your key that you created. On this example, it's showing just the AWS provided one. If you had one on the service, it would just show into this dropdown. To create a key on Terraform is quite easy. It's a line, you just need to put a description. If you want to, you can also add a resource called KMS alias, which is just giving a friendly name to your key. And then you reference this key ID. And then again, the EBS following, you just need to pass your key ID ARN. Funny thing here, when it says ARN, it could be the ID as well. And I'm pretty sure it doesn't work with the ARN. It's either the ARN or the ID doesn't work. And Terraform accepts it, but it doesn't work. I don't know why. If you guys are opting to go with ECS on EC2, you probably would be doing something like that, maybe, I don't know. You can use KMS to encrypt S3 buckets, EFS, RDS. What else? Is there more examples here? DynamoDB, which is a NoSQL database on AWS. EBS volumes.
It's pretty much every service that has some kind of encryption can use KMS.
SSM parameters that you guys need for the project, you can use encryption for that. You actually should use for, at least for the database passwords, to have some more security on that. See, extensive list. To find KMS, it used to live on the IAM service. Now it has its own UI. The service evolved quite a bit in the past few months. So I don't have any keys created. If I go to AWS Manage Keys, I can see the ones that every time that you use, for example, if I never created a bucket with a provided key. So it's not showing AWS /S3 here. If I go to S3 UI, create a bucket, configure it to use the provided one from the AWS, it will just create for me a key here. As you guys can see, I don't have any options here. I can't change, I can't delete. This is all AWS managed. Customer managed keys, I can go and create a key. I'm not going to create one, but I'm gonna show you the UI. As I said, I can use the KMS to manage the life cycle of my key, or I can use external here, and then I can import the material of my key, which is the private key. For example, if I'm working for a company that have its own system that generates keys and manage those private keys, the keys that is used for encryption, I can just upload instead of creating a new one. Or I could use Cloud HSM, which is just another service that manages key. This one, AWS have one, a managed service for Cloud HSM. It used to be quite hard to test because I think it costs like $4,000, $5,000 a service, something like that. But now you can pay a subscription for that. So you essentially, it's nice because you can test the service and see how it works. And the subscription still costs a bit per month. And if you wanted to do asymmetric, you just choose that. I'm not going to create because otherwise I'll have to wait 7 days, and there is a cost, fixed cost on the key, and won't be able to avoid that. Just going back, I think I showed that when I was on S3. I showed you guys the default key, how to enable the encryption on the bucket, right? Its properties, default encryption. Yeah, definitely show that. And I would just pick the key here and save. Next time that I upload a file to the bucket, it will be encrypted. That's it, KMS. CloudWatch. So CloudWatch is the main service on AWS for all the monitoring and analysis and logs, and like part of the SRE on AWS. So it's where you're gonna see how much resource your instance are consuming, logs of your application, where you can create metrics to keep track of your application. For example, you could have custom metrics that will keep track of, for example, how many users are accessing this API URL at any point in time. Or you have metrics for memory usage, CPU usage, those kind of things. So it's a centralized place to monitor your application. Free tier on CloudWatch, you have 5-minute frequency metrics. So what this means is, for example, you create a metric to keep track of the CPU usage of your instance. CloudWatch by default will give you an update every 5 minutes. We'll update that metric. If you need more often, for example, 1 minute frequency or less than that, you can have up to 10 detail monitoring metrics on the free tier. But if you go over that, it is a little bit expensive, the 1 minute frequency. So just have that in mind. If you, I don't think you guys are gonna run over the free tier, but just keep that in mind. If you need lots of 1 minute frequency metric monitoring, it is a bit expensive. You can create up to 3 dashboards. So the dashboard is when you have all your metrics, your alerts, and everything. You can just create a virtual dashboard and then start adding snippets, and then you can see graphics and everything, what's happening with your environment. You can create up to 10 alarms. For logs, you have 5 gigs, that's a max. And you have access to all events. You don't have any limitations on events. Metrics history, I'm pretty sure it keeps for 6 months. And it just deletes itself. So you don't pay for storage of those metric values.
Just one point there, Kyle. It depends on the frequency, and CloudWatch will aggregate for you the metrics. So 1 minute metrics, I think they are there for 15 days.
Yeah.
5 minutes for more time, 15 minutes even more. And well, this goes on for 15 months, more than 2 years. I can send a reference for that.
Yeah, it's depending on your frequency. We'll keep for more time available. Good call. Yeah, that was wrong. So the main features of CloudWatch are metrics, alarm, logs, and events. I'm gonna quickly cover each one of them. Metrics, as I was saying, is the way of keeping data points of your application or your instance or any. I'm pretty sure there is metrics for all the services on AWS. For example, on the Lambda function, you have out-of-the-box metrics for how many calls you're getting on that Lambda. On EC2 instance, you have network, upload, network downloads, disk percent, the reads and writes of your disk, CPU usage, out of the box memory and disk space are not tracked. But if you need custom things, there is something called CloudWatch Agent. It's a software that you can install on your instance, and then you configure more things for your agent to send to CloudWatch logs. And then with this CloudWatch agent, you can configure it to collect memory and disk metrics. Using EC2, ECS, EKS, out of the box will already get you tons of different metrics. But as I said, you can still configure custom ones as well. And then when you have your metrics, you can start building your alarms based on that. So for example, if disk space goes over 90%, send an email to admin to support. Look, you need to raise EBS volume size because you're running out of space. Or if your CPU usage is over 70, 80%, trigger outscaling group scale up and put one more instance on your to be able to handle more traffic or something like that. You can use alarms for billing as well. Not sure if all you guys have done the first exercise from the DevOps Academy, which was setting up a billing alert. So you have played with this service already. And you can use any, sorry, I was going to jump a little bit, but essentially alarms, you're going to use combined with metrics to get some visibility of what's happening. Alarms have 3 ways of reporting. They are either green, red because it ran through that threshold that you configure, or they don't have information required. I forgot the name, but what essentially means that the metric's not working properly, so it doesn't have the information that it requires to measure it based on the threshold that you expect. So it will complain to you, it's insufficient data. That means that the metric's not working for the alarm that you created. Logs, if you guys have used maybe Splunk before, what are the common ones? Datadog, it's just an aggregation tool for logs. You can point using the CloudWatch agent. The EC2 instance by default don't send logs to CloudWatch logs. You need to configure that. You could send specific files of your application to CloudWatch, and then from the CloudWatch UI, you can create queries and find and troubleshoot your application if something is not working properly as expected. More managed solutions on AWS like Lambda functions, ECR, EKS, they have native integration with CloudWatch, and then you can see your logs coming to CloudWatch without any configuration on that part. You still need to give permissions to the service to be able to write logs to CloudWatch. For example, Lambda have an execution role, same as ECS. So I'm gonna use ECS as an example because it's essentially the same. So the ECS will have the execution role, which I'm sure you guys know pros on that already. And that execution role will need to have permission to write logs to CloudWatch. And then you should be able to see the logs from your container, from your task on CloudWatch. And events are a way of delivering, it says on the documentation says near real time, because it's essentially quite fast, can be a little bit delayed sometimes, but based on something that happened on your AWS resource, on your AWS environments, you can react with another action. This guy here combined with CloudTrail being enabled on your account, it can be really powerful because you can have things like if someone uploads a file to a bucket and puts on the wrong folder, let's say I have this folder here that I don't want anyone to upload a file here. I don't know what's the reason, but that's my requirement. If one uploads a file to that folder, it will trigger my event based on a S3 put object to a bucket resource, to a resource bucket on a specific folder, on a folder specific key, and will trigger the event that will send that payload to a Lambda function that will have the information of what key is, what bucket is, and we'll just move that key to the folder that was supposed to be. So you could have some really powerful stuff with these events. And the events can be based on alarms as well. So if an alarm triggers, that's an event, and then you can react to them. To find all the stuff on the console, you just go CloudWatch. This is a very basic overview of the service. This is one of the most complex services that AWS offers, I think, because it has so many things that you can do with CloudWatch. And it gets better every month. Like there is lots of new features for container scanning, container insights, APM. AWS start getting more features on the APM side, which is having more information about how the application itself is running, like trying to troubleshoot the performance of the application. Even for, you now have some features for helping you to do deployments, like canary deployments, to see what's happening. Canary deployments when you are having 20% of your traffic to one of your deployments, 80% to another deployments, and then you can measure different deployments at the same time. So it is very complex. So that's what you guys will use most if you don't go to an advanced use of CloudWatch. The first one that I mentioned before was metrics. So this is the basic UI for metrics. So I have an EC2 instance running, and then as you guys can see, I have out of the box, haven't done any configuration. I have EC2 here. If I click EC2 per instance metrics, you can see it's all from the same coming from the same instance, and then the metric names. So I have here, haven't done any configuration, CPU utilization, networking out, disk write and read, and other stuff. And I could possibly add memory utilization, disk space utilization if I just deploy that CloudWatch agent to my EC2 instance. Based on those metrics, if I click here, it just adds to the graphic, shows me stuff. And then dashboards that I mentioned before, I can create a dashboard and have those graphics as small snippets and then organize around. And you guys have the screens with all the metrics going on, and if the services are up, down, and those kind of things. Then once you have your metrics, you can start creating alarms. Mentioned to you here, you have 3 types of alarms. Okay ones are the ones that are fine, are not under or below the thresholds that you configured. Insufficient are the ones that the metric is not working properly. And alarm is the one that are complaining about something. I don't have any alarms on my account. To create one, just need to select an alarm. So for example, EC2, CPU utilization, oops, not that one, this one, select metric, shows me the graphic, and then I will configure what are the conditions to trigger this alarm. And I'm gonna put here static when my CPU utilization goes greater than 80. And also on an average of 5 minutes, could change that. Probably if I try to use 1 minute, we'll ask if I want to go with CloudWatch detail monitoring, because it's not enabled for my EC2 instance to be able to do this. No, that's not it. This is just when, sorry, this is if my CPU utilization keeps for more than 5 minutes. No, it's actually, I'll go back to what I said before. So to be able to check for just 1 minute, otherwise it will still work, but I will only know that alarm after 5 minutes, because my new metric will come every 5 minutes, even if I'm checking for 1 minute period. And then the next one will be like, what happens if that alarm triggers? So I could trigger an outscaling action, or maybe an EC2 action, like let's say, if the CPU utilization is below 10%, just shut down the instance, not being used anymore. And when that happens, if it's on alarm, which means it goes under or below your threshold, when it's fine, or when it's not working. So probably when it's not working, it would be nice to maybe send a message saying, look, the alarm is not working properly. So cover metrics, cover alarms. Then we have logs. CloudWatch logs are organized by log groups. If you create a Lambda function and you don't specify anything, it will by default create a /AWS /Lambda / the name of your Lambda function, and will dump all the logs there. Most of the services that have native integration with CloudWatch do that. We'll do a /AWS /name of the service /name of your resource, and we'll just dump the logs there. If you want a custom one, you will have to create the log group by yourself. So the only parameter that you need to put is the name. There's nothing else to do here. And then you just need to point your service to, instead of using the default one, use the one that you just created, if you want to have your own organization. Those log groups here can be subscribed to other services. For example, Kinesis firehose or a Lambda function. For example, I won't be able to show you this because it's not included on the UI. You need to do through the CLI. It's one of the things that AWS have that it's only available on the CLI. So essentially, let's say my EC2 instance is dumping logs to this log group here. I can subscribe this log group to a Lambda function. And let's say this Lambda function will keep analyzing my logs. And if it finds something specific that I configured, we'll just do something.
You can do that in the UI, Kyle, in the actions.
Okay.
Yeah, you can create a Elasticsearch subscription filter or a Lambda one.
Yeah, that wasn't available a few weeks ago.
Yeah, it changes so fast. You'll see the events one when you get there.
I have some very complex CLIs to do log group subscription.
Yeah.
Yeah, then you just need to, you can select your Lambda. You can do that. Yeah. You still can't do Kinesis here. So you have Elastic subscription and Lambda subscription. Still don't have Kinesis here. You can link to a Kinesis firehose and then just dump to somewhere else. That is really handy for things like if you're not using CloudWatch logs for your main log aggregation tool, you're using something like Splunk on your company, and you want to send all your CloudWatch logs to Splunk, because things like ECS, Lambda will by default log to CloudWatch. And then from that, you want to send to Splunk. Then what you can do is you create these subscriptions to another service that will, from that service, will forward to Splunk or any other aggregation tool. It's really handy for data lakes as well, for the data analytics things.
Firehose only supports as a output Splunk, Redshift, S3, and one more. It doesn't integrate with everything, but it's pretty handy, yeah.
So as I said, it's really powerful product, the CloudWatch. And the logs itself, when you are inside a log group, you have log strings. Normally this is like just chunks of aggregated data. Most of the service will start splitting every day or every few hours, depending on the amount of data. And then inside it, you can see that the logs itself. And then, for example, this was just a JSON object doing something. And then I could use this filter event to query my logs as any aggregation tool and use, for example, JSON inputs item.user_id equals to this one will bring all my logs based on that field. Essentially what a logging tool does. You have the insights here, which is a very powerful tool that it has some kind of AI to help you analyze your logs and find things that are wrong. And the last one is events. So as I said, you can, based on anything, not anything, but virtually anything that is happening on your AWS environment, pretty much any API call that is being tracked by CloudTrail, you can create events based on that. So you can use your own, you can create by yourself the event JSON payload here, or you can use this tool here to help you to build it. It can be based on an event, or it can be based on a schedule. So I'll just show you a quick one based on an event. So I can filter by a service, for example, S3. And then it's showing here all events because I don't have CloudTrail enabled on my account. Again, be aware, CloudTrail, it's paid feature. It's not included on the free tier, I'm pretty sure. And it can be a little bit expensive if you're using a lot your accounts. But if I want to go up to object level operations, it will warn you that I need to have CloudTrail enabled, but that won't work if I don't have it. I'll just hit OK, and then I could potentially do specific operation, put objects on a specific bucket name, that is the DevOps Academy test. I could add more bucket names for that condition, and essentially gives me the pattern that I need to use. So request parameters, bucket name. This is just a helper to build that JSON structure. And then, okay, if that happens, if it's a AWS API call on a put object for DevOps Academy bucket name, what do you want me to do? Then you use the targets. So you can add one or more targets here. And then AWS provides you a few options that you can do, a few actions that you can do once your event is triggered. My example that I was using was running a Lambda function. So it could be, okay, if someone puts an object on my bucket, runs this Lambda function, whatever, that will remove the file to another folder. And that's it. Anyone has any questions? We won't have any exercise on that in none of those things. I think there is one on S3 to create a website host. One, to give you guys more time to work on the projects, and two, because you need to do some CloudWatch on the project itself, show some monitoring and stuff. So it's part of the project. We'll give you some chance, not push you too much for this next 2 weeks.
Yeah. One last thing, Kyle, in the events, I just saw that if you click there, yeah, look at the notification on the top. No, the events again, the dashboard. Yeah, so events now is part of Event Bridge, which is basically another subservice in CloudWatch. But Event Bridge was used for integrating with external partners like Datadog, Auth0, well, and a number of other services. And now it seems they're moving on to incorporate events inside of Event Bridge. So no surprise if soon the events item will disappear from the menu on the left. So when you create a rule in Event Bridge now, you get basically the same options you have from the events item. So they are consolidating these two.
We use events a lot for triggering messages and emails and notifications and those kind of things. So we'll publish to a topic on a SNS topic. We'll cover that on the serverless part. But if something happened, you publish something to SNS topic, that this SNS topic will have people subscribe to it and will receive notifications for something that is happening.
Yeah, they're very useful. Basically, you can, if you think about automating something in your AWS account, think about CloudWatch events, take a look there if you can capture the event, and then you can trigger a Lambda and do whatever you want to do with this event. So look at the number of the services you have there. So if you grab EC2, for example, you'll have a bunch of events that happen there.
Yeah, for example, if you don't want a VPC credit, you just go and delete. AWS have other services for those kind of things as well. For example, AWS config that can do remediations based on the actions. Just using as an example, that's something that you can, based on an action, you can trigger a Lambda function that goes and do something.
Yeah, and the targets, if you can open, Kyle, I think it's Lambda. Yeah, Lambda SNS, SQS, automation, if you want to remediate, step functions, well, kinesis.
You can also use ECS tasks if you're. I'm talking more about Lambda because those things are normally Lambda, not ECS tasks, but as you guys are using ECS tasks, can be more clear. It's essentially the same.
Oh, there are even API calls there.
Could even like trigger a code pipeline build job based on something that happened on your environment. Cool. I think that was it for AWS. Now we're just gonna do a bit of Three Musketeers. Who knows what a Three Musketeers is? I think you are on mute, Gustavo.
I would say Tim knows everything about Three Musketeers.
He doesn't count.
I don't count.
You don't count, yeah. No one wants to give us an overview of what Three Musketeers is. You guys have been using a lot, which is quite good.
There was a movie called Three Musketeers.
It comes from there. So Three Musketeers is essentially Docker Compose, and Make. And what we are trying to achieve with those three guys is consistency, control, and confidence. It's a way of avoiding that really famous phrase that, look, you said that it was running on it, like it works on my machine. So it looks on my machine. So with those three tools combined, you can avoid a lot of inconsistencies and dependencies across people in a project. And I think you are actually going through this right way on your project. You're seeing the benefits of it, using the make files and the Docker Compose to run Terraform, to run the AWS CLI. You actually avoid that someone is using Terraform at 0.11 and someone else is using 0.12 and it doesn't work for some reasons. So that's essentially why someone just put together those three and created a pattern around it and put some ways of having people to follow some patterns so we can achieve more consistency across the development process. There are a few other there's some other alternatives around for the Three Musketeers. I think this is something that people is always trying to find ways of improve or development in teams. But so far, this one is the best one that I've been across. Sometimes people rely on Bash. Bash is as much as you have Bash on most of the computers today, they are not on the same version, and you will have issues on MacBooks and Unix machines and Windows machines because they use different paths and everything. I've seen some other tools that have like a single dependency on Java. Like, come on, this is a big dependency. This is exactly what we are trying to avoid, not have a dependency. Have something that I grab a new PC, I just need to install Docker Compose. Most of the laptops have Make. I know that MacBooks have a very old Make file version installed out of the box, but is there? Windows don't have Make. You need to have the WSL to have Make. But it's not much. You need to install 3 tools, and then you have any other tool available with a few commands. We like to call 3M instead of keep saying Three Musketeers. And so I have a quick hello world example here. So is anyone still don't kind of realize that you are using that on right now, like on your group projects? Are you not doing that? Silence.
To be honest, I searched about it. I think that the third class you said to search about it, but it was the first time that I realized that I've been using it in a project that I've been working, and I didn't know about this topic, this concept.
Yes, it's pretty much just putting together what we are doing already.
I think the idea is one for all and all for one.
Yeah.
I first thought that Three Musketeers refers to you three. So initially I thought it's something Dennis, Kayo, and Kiko. I thought it's about you three.
We don't have M's on our names. Ah. Good catch. Yeah, so essentially here, this is a make file, and we have an echo target. We covered that, was on the last class. Yeah, I think it was make class, yeah. And then instead of running just the echo hello world, we do a Docker compose run. The --rm is to clean the container after running, the name of the service on your Docker compose file, and then the command that you want to run. And then on your terminal itself, you just do a make echo, and then it will run your echo command for you. I have my terminal. So pretty much the same that we have here. I just want to run one or two times so you guys can see it again. Is it okay to zoom? Can you give a bit more? So
That's fine.
I have the echo there, and my Docker compose run --rm. So that's the next thing here. Sorry, I'm gonna follow that. Sorry. Some patterns when you're doing Three Musketeers. You can do the Docker compose run --rm and make that a value from a variable. And then instead of for each target on your make file, you run again Docker compose run --rm something. You can just do a variable run, and we'll just do substitute by that value and then complete with the command that you need to run. That just makes things a little bit more clear. You can still go one step further, which would be, so on my example here, I only have Alpine. So I'm gonna create a new var called Alpine, and I will do this one and call Alpine. So instead of doing Alpine here, I could just use that var instead. And I know that every time that I use this var, it's actually running my Alpine container. And then I just need to give the command and any. So it's just a way of simplifying, making it easier to read the make file. The idea of the make file is to be clear and easy to read and understand what the targets are doing without asking much around. It should be self-explanatory. And I could also do something like that. If I run my make echo, well, I didn't get anything here. Something's wrong.
The text is empty, the variable.
Yeah, so my make file expects a variable and it doesn't have any value on it. What I can do is text, Kyle, and make. You guys are all pros on that already, doing lots of make files I've seen around on your projects. So essentially just echoed the value of my var. Some other patterns when doing Three Musketeers is for anything that you need to run, for example, this one that is a Docker run something, like it's gonna execute something inside a container. We just give a normal name, just a normal string name. And if you need to do, for example, echo, and then just echo text, which would be like it's not running the Docker one, it's using a tool that I need to have installed on my computer. It's a dependency that I need to have installed on my computer. We usually do underscore before the name of the target. So that is just a way of indicating that whatever is running on that target, has a requirement on your local computer. It could be maybe a Python script that is running or Java, something that is running. This one, his echo is going to work, but it could be something more complex. So normally when you have a underscore, it means that is a specific language requirement. But for these 3 Musketeers, most of the times you end up running things under the Docker one. And so will be just a general name here. Something else is passing variables around, but I even think that is even more for the Docker Compose. I know it's here, the environment variables, but I think this is more for Docker Compose, will be just more a review. Yeah, this one here uses a more complex scenario. So underscore test, you are using a domain specific language to run that. So in this case, a bash, and you're going to run a script, a bash script. People, when you start getting more advanced with 3 Musketeers and you start having a more complex make files, you start having some issues with the bash, with the shell on your make, because a make runs a shell inside the make file. And it has some limitations when you need to pass variables around, when you need to change the value of your variable in different targets of your make file. It starts getting challenged. So people tend to, when it gets too complex, to instead of putting your script under your make file target, to just run a bash script, like this example here. So underscore test runs a bash script, and then the bash script will do this more advanced stuff, because it's more flexible, the bash, than the make files. I don't recommend doing that. One reason is, as I said before, bash is not available into all operational systems, and it has inconsistencies. So something that runs on Unix sometimes don't run on Mac, and sometimes don't run on Windows. I think if it's doing too much things on a makefile, you're probably doing something wrong. You probably should be splitting around your work and trying to think on a better way of doing, instead of going really complex. Makefiles are not supposed to be too much business detail on that, too much logic. So let me just see if I forget anything. Docker Compose, shortcut, the beginning with underscore. It's a good practice to have a clean target and run a Docker Compose down with remove orphans. Every time that you run Docker Compose, if you don't specify the network, which is by default, it creates a new network bridge for you, and it has a limitation. I think you can run 256. It will reuse once you've run the first time. Docker Compose creates the network bridge. If you run again, it will reuse. It won't create a new one every time. But if you are having different projects using different services and different Docker Compose, will start adding up, and you can run into errors saying, oh, you run out of network availables for a Docker. So, and this command here, so it will clean up the network drivers on your Docker Compose, and we'll clean up the images as well. So it's just a good target to have, good practice. And then you can, after your echo, you can maybe do a clean, make clean, or run before the echo, you run a clean, for example. Environment variables. Let's say we need to pass a variable to inside my container. What I can do is I'll export a new variable here called test, and the value will be Kyle. I like this target here called shell. What it's doing is it's running my Docker Compose, executing my Alpine service from my Docker Compose. But what it's doing is it's overwriting the entry point. So that you guys remember what the entry point of an image is, right? So if I do entry points nothing, it means that I can pass after the name of the service. I can tell like what I'm going to run. Alpine is not a really good example because the entry point, it is already nothing. So if you see here, it's a Docker Compose, and I just run straight echo. Whatever command I run after the calling the service, it will execute because it is expecting the next command. But if you have, for example, Terraform image that is defined to run Terraform command. So if you run the Terraform image, you will run Terraform CLI. But you want to use some other tool that is installed on the same container. And then you override the entry points, and then you run your service, and you tell what is the command that you want to run. So as I'm running sh, this is the shell terminal that Alpine have. It's not bash, it's sh. So if I run that make shell, I'm gonna hold on here just for a second. If you go back to my Docker Compose, I can have a property here called environment and say, what was called? Tests. Pretty much saying that for this service here, use my environment variables test to expose inside my container. And if I do a make shell, it will run that Docker Compose that override the entry point and just run sh on it. And then if I do a env here, you can see all the env vars that I have on my container, and one of them is test. So I could potentially just use that value inside my container. But this one is more about Docker Compose. And if you remember, you also could do env file and specify some file here, and then have on that file all the variables that you need to pass along to your container. There's a small bug on the Docker Compose, which is if you have two services, let's say Alpine and Alpine 2, and this one uses the env file, some file, and this one doesn't. If you try to execute this one here and you don't have this file, it will fail. This is because Docker Compose validates all the services before running. Even if you are just calling one specific service, it will do a validation to all services first. So it's a known bug, but it's expected way of working. And that's it. Did I forget to cover anything?
No, don't think so.
That was a lot of content in 1 hour.
It was. Yeah, should we take 5-minute break and go on to the next content then? Any questions?
No, it's clear.
5 minutes then. Thanks, guys.
Right, 5 minutes.
Let's do 5.
Your cat wants to learn 3 Musketeers as well, Tim?
Yep, she saw it us, mate. Oh, not happy.
A quick break as well. Hey Kiko, did you see the rain today?
The what? Sorry.
Did you see the rain today around midday? And well, now you couldn't. You were here, but I'm pretty sure it was snowing.
Yeah, I don't think it was snow, but yeah, I saw a few things falling.
Yeah, it was either hail or snow, but I think it was snow because it was -1 degree.
I think it was hail. Yeah, I'm not sure.
Yeah, there was hail. My kids were just outside. I told them you might, get some big rocks.
But it's snowing in quite a few places today, around close to the city.
How are you guys doing with the second lockdown 2.0?
Not easy.
Yeah, with kids, it's really, really tough.
As you said, with homeschooling, everything gets really, really harder during the morning.
Yeah. You got any kids?
Yeah, I have one in prep. So yeah,
yeah, it's tough. Yeah, I got grade 5 and grade 3. Lovely.
Yeah.
The poor kids, it's unfair to expect all this from them. Yeah.
True.
So I had one question with this Terraform. Like I remember when we use CloudFormation, we tried to define the expected state, right? I would like to have this setup, and then it would go and do it. But let's say if I have to create 10 resources and similar kind of resource, but I have to pass change just the name. In that case, yes, Terraform offers this looping. Like I'll pass out an array and it would just loop it and create these things.
Mm-hmm.
In CloudFormation, now the problem is, let's say it goes and creates it, and on the 6th instance, it fails. If that is it loops and it fails in the middle somewhere. And if I want to troubleshoot it, it's going to be a bit difficult, right? What happened, where it fails and all that. If I'm looping, because I'm trying to use Terraform as a programming language now. But
you should have in the Terraform logs when it's deploying,
okay,
some kind of message about that specific resource and why it's failing, or at least some hints on why it's failing. Maybe not you won't give everything. It might give some guidance and some directions to trace back. Okay. But I haven't seen many cases of failing during a loop because for any reason, unless the resource already exists or something like that. You shouldn't see a lot of these issues, I would say.
Okay. So I remember there was a requirement, like at some point we had to populate some VPC routes, and in using CloudFormation, we ended up experimenting with CloudFormation macros. Mm-hmm. That it ended up generating this massive CloudFormation underneath, but still it uses one by one,
yeah.
looping it. Maybe this one is doing something similar. This is just API calls constantly, 10 times 10 API calls, something like that.
If you see this kind of error, just reach to one of us and we can try to figure out what's happening.
Oh no, this is just I was just curious about it because yeah. Because I thought like Terraform also you declare something. This is the state I want. Yeah. But I wouldn't want to write loops and logic and all that in the template itself. It becomes another language. that I end up using. It can get pretty complex, right?
Yes,
I saw some pretty like nifty jobs that people did with CloudFormation, Terraform.
All right. Let's start, Kiko.
Yep. Let me share my screen here. Let me see if you guys can see it.
Yeah,
you can see it.
Cool. Yeah, I'll be covering today both CI/CD, some concepts around it, and also GitHub Actions as a tool to implement a CI/CD pattern. But talking a little bit about CI and CD and what it's about. Basically, both CI and CD are made of a pipeline, which is pretty much a sequence of steps, right? So if you look here in this example, we have this pipeline, which is pretty much a CI and CD pipeline, because it does a few things on the CI side, which is pretty much building your artifacts, compiling your application, running a few tests, either unit tests, integration tests, or anything that you need to run, security tests, either performance tests, so any kind of steps, and this can go pretty complex in terms of the steps that you would have, and it goes all through the deployment into production, going through all other environments as well. So this would be a full CI/CD pipeline, right? So you have all those steps running normally in sequence, or at least there is some dependency on success on one in order to run another one, but you might have a few steps running in parallel. So it's just a way of declaring a sequence and kind of a rule in order to have all your new code deploying into an environment, right? Some examples of the steps that we have here declared and detailed. It's not mandatory. It's normally I would say the least steps that you're gonna have. So some kind of test. Normally you wanna do some tests in your pipeline. So either checking syntax, linting, unit tests, some basic tests of what you're committing to your code, and this is normally runs once you commit new code to your repository. Then you have some kind of build step, and this can be building the artifact itself. So it will depend of what you're delivering. So if you're delivering some kind of Go app, you're probably gonna be ending up in this step with a Go binary. If you're writing some kind of binary Go. If you're running some containers as this build step, you ended up with a container image. If it's a Java application, maybe a .jar file. But yeah, it can be pretty much any artifact itself that you create in this build step. And again, it's just an example, right? It might be, you might call this build step as Docker build. It doesn't need to be build itself, but it's just an example. Then you normally have some kind of deployments, and that can be just a deployment in a development environment, or QA environment, or some test environment that you're gonna be able to run a few either integration tests or validations from some kind of monitoring system to check a few things around your environment and your change that you're doing, which we normally run on those post deployments, right? So it can be integration tests and smoke tests, and even checking for performance. Maybe you have a new API that instead of replying, I don't know, 100 milliseconds, now it's replying 300 milliseconds, and that can be a really issue for your application when it goes into prod with all those tracks. So in this step, you normally want to test those kinds of things as well. And then once you are satisfied and you're happy with all those post-deployment tests, you can run something or deploy something in production, right? And there are multiple ways into deploying into prod, and I'll cover that later in this. So talking a little bit about and trying to split this whole process, right? The first one would be CI, which means continuous integration. And is there anyone that that can talk about what is the main objective of a CI in a, let's say, in a CI/CD pipeline? What is the main goal of the CI process?
So to identify the integration issues as soon as possible, like whether your piece of code is working with the rest of the code?
Yeah, it doesn't even need to be with the rest of the code. It might be just, it might just fail through some unit tests and some things that is already in the repo. So you have a unit test that expects to have some behavior in your function. And right. When you do a change, it fails. So, but you're right. The idea is to be notified and know about issues that you are implementing in your application as soon as possible, right? Otherwise, you're gonna have maybe 10, 20 commits, 20 changes, and once you're delivering that into even in a further stage of your pipeline, you're gonna find out that your first change is having issues, right? So that's the main reasons to have a CI, is to try to catch issues as soon as possible, so you can fix them and you don't have a lot of issues in the further stage. So yeah, nice one. And talking about a little bit of and this is the continuous integrations is, I would say, is the easy part to implement, because you don't have a lot of risks to your environment, right? You're not playing with prod, you're not playing with not even playing with any environment in the integration here. It's just a matter of testing that the code you're delivering, the change that you are committing to the repository, it's working as expected. So it's pretty easy to implement it with some unit tests and some basic validations, and there is no risk of in implementing that to put your production application or production environment in risk. So everything is done prior to that phase. So it's pretty safe, and it's pretty important in any agile and DevOps, let's say, environment. And jumping into continuous deployment, this is a little bit more complex environment where you have all your test users validate some of the changes, or even in production, if you have deployment into prod. And you need to be very careful when you're doing those deployments, because you may be putting your application or your company or your software at risk. So that's why you need to have as much as let's say complete CI tool or CI pipeline to test everything that you can, to make sure everything works. All those previous environments integrations as well. So performance tests if you need, integrated tests. So it's very important to have all those previous steps well implemented, and testing everything you need before you have a continuous deployment into your prod environment, right? So that's critical. And in CD process, which is normally when you are deploying your new code to a prod environment, let's say this way, you can have multiple deployment patterns or definitions here, which are mainly those three that we have here. So the first one would be in place, blue-green, and canary. And this exists for a very long time, and there are very common patterns in a deployment process. They just became very much more popular with cloud, because with cloud, cloud gives you that flexibility of having multiple environments. in the past you would have some parallel environments which would cost a lot of money, and with cloud you can have those parallel environments for a short period of time. So it's not as costly as it was before. So cloud brought this possibility to many more companies instead of just big companies that have a lot of money. In the cloud, you can have that pretty cheaply. So it brought these patterns and these concepts and those benefits with it. So basically, explaining each of those CD patterns in place is just pretty much replacing in a rolling method your application. So if we talk about containers, and let's say that we have ECS hosting our application, in place would mean that let's say that you have 4 tasks running for a specific service. In place would just try to replace one of those services at a time, or sorry, one of those tasks at a time. So you would replace the first one, replace the second one, the third one, and the fourth one in a sequence. Or you may replace 2 and then 2. So you can define those kinds of things during in an in-place rolling deployment. But normally you're just replacing everything that you have in place, right? You don't have a parallel environment to test those 2 environments and compare results and compare things. So that's one way to deploy. It's not the best because if you implement something that is not behaving as expected, even that you have all the tests before, you're gonna impact a lot of users, and the rollback might take a little bit of time, right? You'd have to roll back your entire deployment, which is not ideal. The blue-green is when you have pretty much 2 parallel environments. They have the exact same configurations in terms of power, CPU, memory, everything is exactly the same. And you have both running at the same time, right? So if you have your version 1 running on one of those environments, let's say blue, and you deploy a new version, you normally deploy the new version in the environment that's not being used. So in that case, the green. And you normally do a DNS change. So instead of pointing your application URL to the blue deployment, you just change that into green, and all your traffic starts to go to the green once that DNS record is replicated and propagated through the DNS system. So in that case, you move all your users at the same, I would say at the same time, but at once. Some users will still be using blue if they are connected to that instance. The DNS propagation might take some time to move everything to green, but you're moving everyone at the same time. That's the idea. And if you have an issue, just change. You just change the DNS record to point back to blue, and it should be fine. You have a quick rollback in terms of getting users back to your working environment if something goes wrong with the green. And then we have a canary deployment, right? So canary, it's also, you have 2 environments in parallel. It's similar in the way of the blue-green, where you have both environments having the same power. The difference here to blue-green is that, let's say that you have a new version. So you're running your application version 1, everyone is going to that endpoint, version 1, and then you have a version 2 that you deploy in a parallel environment, right? So what you do here with the canary deployment is that you can redirect part of your traffic, so part of your request, a percentage, let's say 10%, 5%, 25%, you can send those in the use case of the image, 25% of the users that are requesting access to your application, you are redirecting to the new application. So in that case, even if something is wrong, not all your users will be affected. And this is something that you can use to test some new features with a specific, a reduced number of users that you have. And once you feel that, okay, everything is working fine, so you switch between 50-50 and then 25 75, and then 0 or 100 to the new version. So you do a migration in steps with different numbers of percentage between those two environments, and that provides a very good user experience, because if something is wrong and you're just sending 5% of your users to the new app, you're not affecting everyone, just 5%. So those are the three main models. We have also red and black and a few others, but I would say that those three are the three main deployment patterns that we have in a CD process when you're talking about application changing in a production environment, right? There's also feature flags, which you can also use similar things in terms of sending a new version of your application or enabling a feature to your application, but to a specific number of users. But that's not in the that's normally in the application level. It's not in the infrastructure level, and all those three deployments are on the infrastructure level of the deployment process, right? Because you're playing with Route 53, you're playing with different environments, even that they are prod environments, but they are in parallel environments for same purpose, right? Creating a pipeline. So before that, any questions into those three patterns here? Any comments? Anything to go further if you guys need?
Which one is the one that you use the most in your workplace?
That depends of the company, how much they want to spend and how reliable they want to be for the users. I would say that the simplest one, and normally when there is not a lot of impact to user, the in place is used. But the majority of big companies will either use blue-green or canary, I'd say, because of the fast rollback and the capability to pretty much to rollback, I would say, yeah. And the cost is a lot more for those two, because you have the double of resources running. But for big companies, normally this is not as critical as having a new change impacting a lot of users. But we see the three cases very commonly. Any other questions before moving forward? Cool. Pipelines and how to create pipelines. So this will pretty much depend on what tool you're using as a CI and CD tools. But the general use case of a pipeline is that is a set of instructions. So it can either be batch script, PowerShell, or in the best case scenario, 3 Musketeers as Kyle was presenting today. So ideally, you're gonna have something like a 3 Musketeer running those steps in a pipeline as much as possible. So you can validate that what you're running on your local will also work during a deployment process, right? Because you're gonna build your containers on local or compile your application on local. You're gonna run your unit tests on local. So everything that you run on local, when you push your code to the repository, you expect to behave the same. So it's a good idea to use 3 Musketeer as the steps in your pipeline. And normally what you have as a pipeline and is all, or I would say all version control systems like Git or GitLab or Bitbucket, they will have some kind of webhook, which means that once you push new code or merge code or do any actions that will change some of the code, it can normally integrate with some CI tool to run a pipeline, right? So I'm gonna cover that in the GitHub actions, but you can have an actions to run a pipeline once you have a new code in a specific branch or in a dev/something branch or in your master. So normally a pipeline is executed once a specific event that you define in your pipeline happens in your repository, right? So pulling, pushing codes. It can be cron jobs like events based on schedule as well. But the majority of the pipelines, especially through code change, will be based on pull requests and commits and merge. I mean, there's plenty of tools, and it will be impossible to list all the tools here. Some of common tools that we have, Jenkins is one of the oldest, is open source, and there's plenty of people using there. It's not a very, I'd say, updated or with the latest features tool, but it still does the job. GitHub Actions, which we're gonna use in this in the DevOps Academy, and we recommend you guys to use as well in your project. It's very common. It's integrated with the GitHub, so if you have your code in GitHub, it makes sense to use GitHub Actions. GitLab also has its own, very similar to GitHub Actions. They have their own runners, or you can have runners on your private. You can have private instances runners, but it does the job as well. CircleCI, Bitkite, and AWS Code Pipelines are others. DevOps, Azure DevOps, and plenty of others. There's you can have I don't know, maybe 20, 25 tools in the market just for that, and a few specifics for deployment with Kubernetes, like Harness and what's the name of the others? Spinnaker. So there's plenty. Any questions on CI and CD concepts here, guys? Before I jump into GitHub Actions, so we can see more about a specific use case of those processes and concepts. And I just mentioned Azure DevOps because of our Azure guys here. Otherwise, I wouldn't. I know they would be sad if I don't mention that, especially Danielle.
Thank you, Kiko.
Yeah, I know, man.
Man, it's getting better, man. Come on.
Cool. I'll just jump to GitHub Actions. But some of the concepts we'll pretty much see again here on the GitHub Actions specific class. Cool. So GitHub Actions is, as I mentioned, is just one tool. It can do pretty much everything. It can do CI and CD. I would say that it's easier to have as a CI, especially if you need to integrate with other cloud providers and things like that. You need to create your own things and create some scripts. But again, it can be used for both. It's not a specific tool for CD like Spinnaker, for example. It does both. It has a few concepts, specific concepts, and that will change from tool to tool, but it's specifically for GitHub Actions right now. It has runners, workflows, job, actions, and steps. I'll go through those right after, but those are the five main building blocks that we have in GitHub Actions. The first one would be runners, and runners is pretty much what we will execute your pipeline. So it can be some flavors of machines. It can be Linux, Mac OS, and Windows, and also containers. And you can have both GitHub hosted runners, which means that those runners, let's say instance or containers that will execute your pipeline, is hosted by GitHub itself. So you don't have to manage those. It comes with lots of tools. If you see, I would say it has pretty much all languages installed. It has Docker, it has Docker Compose, it has Make. So it has pretty much everything that you can imagine in that instance. AWS CLI, PowerShell, pretty much everything. So it serves for a lot of purpose, and you do pretty much almost everything that you need. But you can also have your own runners, which means that you install and deploy, let's say, virtual machines, can be on the cloud, can be on your own data center. And those are called self-hosted runners. And in that case, you need to manage those, but you gain on other sides, specifically for, let's say, banks, financial institutions, health institutions, where you need to make sure that you have control of what you're running, how you're running, what kind of version you have on your environment. Then you're normally gonna go with those self-hosted runners. But again, you lose in terms of you need to manage those things, right? So for our purpose in the DevOps Academy, we're gonna use the GitHub hosted machines, normally Linux, to run all your pipelines. But yeah, you might need to use self-hosted runners depending on you're gonna work. So the next building block here is the workflow, and the workflow is pretty much the description of your entire pipeline, right? So in that workflow, you're gonna define all your steps that you're gonna have, what images you're gonna use to run a specific step, the environment variables that you're gonna need, how we're gonna start your workflow, so which event will trigger your workflow, and so on and so forth. So the workflow is pretty much the entire definition of your pipeline here. You define your workflows in the .github/workflows folder. And if we look into our, let me just jump here quickly so you guys can see some examples of workflows here. So we have the .github workflows, and here we have a few workflows defined for the Academy repository. For example, this label one, and you have all the definition of these workflow. I'll go through those definitions during the class. That's why I'm not showing that. But again, the dashboard, you have all your definitions of your workflow here. So this is pretty much a workflow. And in this case, we have a single job, but it can be multiple steps. Coming back here to workflow, cool. So that's pretty much the workflow is the description, the entire description of your pipeline. So inside your workflow, you normally have those things, which is job, actions, and steps. So a job here is a set of steps. So imagine that you can have multiple steps inside a job, but the idea of the job is that it will be executed in the same runner. So all steps that belong to a job will be executed in the same GitHub runner instance. For example, if you're using self-hosted run, you can, for example, use self-hosted runners to run one job and use a GitHub hosted instance to run the second job. Even if you use both jobs that you have in your pipeline in a GitHub Actions instance runner, you risk that both jobs will be running on different instances, which means that if you, and this is important because if you need to use some of the artifacts that are being generated in one step, in the next step, without having to send those to a ECR or artifact or any repository, you need to have those steps in the same job, right? So let's say that you compile your application, so you have your binary file, and now you need to build a Docker image from that will have that binary. You need to have both steps, one for compiling your application and one for building your container in the same job defined in your pipeline. Right, so that's the main thing I would say for a job is if you have dependencies between the result of one step that you need to use in the next step, just make sure that everything is in the same job. You can also have actions here, and action is an individual task or is a step, let's say this way. that pretty much uses an action from the GitHub marketplace. So GitHub, and this is very nice from the GitHub Actions. You have plenty of steps that are already pre-built, and they call those steps actions that does a specific thing. So you can have an actions to, let's say, label your pull request based on a few configurations. You have an actions to comment on a pull request. You have an actions to pull your repository. You have an actions to deploy something to a specific environment. Like you can have an actions to deploy a new task, a new container to a specific task definition. So if you jump here, you can see everything that is available in the GitHub marketplace. I'm not being able to click here. So you can pretty much see that there's lots and lots of code quality, code review, API management, mobile. So if let's say AWS CCS, so you have some tasks already, some actions that is pretty much ready to be used with a few configurations, and it's easy to use. And I'll show some of those things right here. For example, this content label is using one of the actions. So it's using this action here, which pretty much does some labeling around the pull request based on a configuration that we have here. So we don't need to write a lot of lines of code to, based on the type of file that is being included in the merge request and the pull request, to do some kind of adding some kind of label or commenting on things. So all the logic is already here. So it's very useful. It's like Docker image, right? Where you can use some work already done from someone else that is willing to share their code. So it's a very good thing on GitHub Actions that helps a lot in terms of making your builds and your pipelines easy to create, let's say this way. And then you have this step, which again can be an action itself, or can be some kind of make command that you want to execute using Musketeers, a bash script, or any other execution that maybe Go build or Maven, anything that you can imagine can be executed in a step very much. And this is just a workflow, or just a diagram of a workflow that exemplifies that everything in a job will be run inside the same instance, and the other job in another instance. And you have multiple steps inside one job. You can have a single step as well, but if you need, you can have multiple steps. Any questions up to this point? Nope. All good. So here we have.
Sorry, can you? Sorry, Kiko.
Yep.
Can you have as many steps you want, or do you need to follow any basic rules like
no, you
one
can
step
have,
or 2 steps?
You can have as many steps as you want, or as many steps your pipeline needs. So you can have, for example, security validations of your container image, security validations of your source codes. You can have linting. You can have as many as you need in your pipeline. There's no restrictions, no pattern, no rule here. Just make sure that you do everything that your pipeline needs.
Nice, thank you.
No worries. The only thing that is required for a workflow here is to have at least one job with one step or multiple steps. Otherwise, there's no reasons to have a workflow if you have no job. And as I mentioned, you normally have an event that will trigger a pipeline. If you just jump into the workflow syntax documentation, I think it's easier to see here. You're normally going to use the on syntax here, and then push, pull request, or schedule pretty much. So in those examples that we have here, these will be triggering your pipeline on a push event. So anything that is pushed to your repository for any branch in that specific path that is being ignored here. So anything besides this path doc would trigger the pipeline and the steps defining in those pipelines, right? If you want to, for example, just run in any, when something, some file like .js is changed, then you use that. So you can mix and match in a single pipeline. So you can have to run something on push and something different on pull. So you can pretty much create your own or multiples workflow depending on different different events, right? So again, if you jump here back in the Academy, this, for example, just runs on every pull request, no matter which branch, no matter which path of the file. So on every pull request, we're going to execute that. And if you see, for example, this dashboard is on a schedule. So instead of on pull request or on pull or on push, it's just based on a cron, which is a specific days of the week, days, time, and things like that. So, and another one here is an example. These merge apply. So these will be, for example, on push for a specific branch master. So we only execute this workflow if you have push coding, if you're pushing code to the master branch, and only if the path is this one. So as I said, you can configure your pipeline based on a lot of stuff, and you're probably gonna use those things in the pipelines that you're gonna have in the project, because you're gonna have a Docker file there, you're gonna have Terraform there. So you don't want to run Terraform plan for every change that you do on your Docker file, right? So you're gonna need to think in what kind of automation you need depending on the file that is being changed on your project. So you guys can use some examples from our own repository here that has some of those push to branches or paths. But yeah, you guys gonna think in ways of doing those things inside your project.
Hey, Kikos, one
Yes.
question.
Yep.
So this YAM file, it's basically where you configure your jobs and steps.
Yes. In this, oh, sorry, go ahead, man.
And after, so all this CI and CD will be in the same file, basically.
It depends. I would say that normally no, because your CI will normally happen in a pull request. So for example, I'll use this example of the GitHub Terraform, right? So this is on a pull request. So this would be, let's say, our CI, right? We are validating that everything is in place. So the path is the same. So whenever we have a pull request changing files on this specific folder here, we're gonna run this. So this is more of a CI process.
The CI, okay.
Yeah, because you're just validating. If it was, for example, a Docker image, we will be building the image here and testing things around that image. But we are not deploying that into a production because it's still a pull request here. The workflow that would handle the CD would be the merge here, which happens on push to a branch master using the same path. So what happens is we run the CI when you have a pull request, and we run the CD of the same file when this code is merged into master. So that's a good use case and a very good pattern for a CI and CD differentiation in terms of pipeline.
So when you guys merge into master is when gonna run this job, but the testing phase in master will not run because it's not a pull request. So it's just doing the CD in master, but not the CI in master.
No, we don't do the CI master because we already validated the CI, and that's a specific use case because the Terraform will behave in the same way, at least for this case here. But depending on how your application is structured, the containers and how you deploy, you may need to run some additional steps during your deployment process if you need that are similar to that you run in your CI process. So it would depend. I won't say that everything that is running CI never will be run on CD. Ideally, you won't because otherwise you're duplicating things. But there may be some case that you need to run some additional steps or some repeat some of the steps that you run on your CI in your CD. But ideally, you have those things segregated and should be isolated. Let's say this way.
Awesome, thank you.
So here we have just a few examples of a few things that we can use. These would be call builder running on pull request and some steps here. So each of those is a step. So we have a checkout step, then we have a run step, which will run a bash script in a specific folder, and then another step and another step. So it's pretty easy. It's not complex as long as you have those scripts and those logic well created, either ideally through make, compose, and Docker in the 3 Musketeer pattern, or even through bash script if you need. But the logic of the pipeline here is just run a sequence of scripts or make commands or things like that. So there's not a lot of if else's and things like that in that kind of pipeline. All the logic goes into the step execution, let's say this way.
So these, sorry, Kiko, these steps will run in order, like one after the other, as we have written?
In that case, yes. You can define steps to run in parallel. So I think we have here jobs, steps. You can define dependency or no dependency step run. I'm not sure if it's easy to find here, maybe, but I can send you some examples of things running in parallel. But yeah, it will depend on your pipeline, how it needs to run. For example, you might need to run 3 different security checks on your code, and you don't need to wait for them to for the first one to execute the second one. So you might want to run the 3 steps in parallel if you want. The steps in a job, they need to run in parallel, if I'm not mistaken. I can check that for you. But the jobs that you have in your workflow, they can run in parallel or in sequence. But I think that the steps inside a job needs to run always in sequence.
Okay, thank you.
But I'll check that for you. I think, yeah, strategy is not easy to find here. Yeah, but I'll come back to you and share with the team in the Slack channel. Cool. I think we have a few examples here. So yeah, yeah, that's the example here. So in that case, we have 2 jobs, and the alerts needs the build to be completed successfully to run. So in that case, they won't run in parallel. There is a dependency created between these job alerts and this job build. Here we can also use Docker image to run some steps. Just in the job, instead of using the run command or the use command, you just use the container command, and you pass all the variables that a container will need. Some image, environment variables, port, volumes. You can use that for specific testing purpose if you want. But again, I would say that using Docker Compose and make files and would be a much better solution than using this pattern here. It's just available. Something important in a pipeline, in a workflow, is normally environment variables and variables that you pass for the execution. So that's something that you can use in GitHub Actions. If you come back here, I think it's easier to show through those examples. But here you have all those environments here, which are using specific secrets, and secrets is normally things that you don't want to share or you don't want in your repository, as it could cause you some damage, I would say this way. But ideally, you can have values here if you don't want. So it could be environment equals prods, or I don't know, environment equals test and things like that. But yeah, you can also have secrets for those. And these are things that once this code is being run, all those environment variables will be accessible by both the checkout and, sorry, just for the this run make gh apply here, not for the checkouts, because it's tied to this specific step here. But yeah, that's what we use for our GitHub apply Terraform. So we need the access key for AWS because our state is there. We need the token from GitHub and the TFR to be used by Terraform here with this environment variable. So the environment variable, and you guys will probably use that in your project as well, will be needed in order to make, especially be able to access some environments, like have credentials to access AWS or ECR and things like that.
Nico, Francisco.
Yep.
In our projects at the moment, are we able to add secrets? Because I couldn't find how to add them.
Yeah, and that's something that I'll add you guys. I think there's an issue for Terraform code. We are adding you guys as maintainers, and as maintainers you don't have access to secrets. But I'll change the permissions for everyone, and you guys will be able to access secrets.
Right, thank you.
Sorry,
yes.
One more thing. Those environment variables, those secrets, how do you populate those secrets?
You mean in secrets?
No. Yeah, please. Yeah.
Those things here.
Yeah.
This is created. That's what things that they don't have access. So here you have secrets in your repository, and you have all the secrets defined here, and you define those values here. They are not accessible. I can't see what is here. It's pretty much hidden for me. I can update, I can remove, but I can see the values. But those are defined in that step, in that place, and then you can use those in the in the workflow here.
Okay, nice. Thank you.
You can also integrate with different tools and make calls to HashiCorp Vault and things like that. But for us, I think this serves the purpose, so we don't need any external things, and we can use the GitHub Actions, GitHub secrets itself.
Okay.
Cool. So the environment variables and the secrets. So I could show them here, but.
May I ask you a question?
Yep.
Do you know if these GitHub secrets, is it possible to access from using external CI/CD tool?
I would say possibly yes, because the secrets are, I don't think they are tied to GitHub Actions, but I'm not sure. I'll have to test. I think you can, for example, try to use API calls to get those values, but I don't know.
No problem.
I just checked the GitHub API, and yeah, there's a REST API endpoint for that.
Cool. Yeah, then you can.
Nice.
You have a token, you just pass the secret name and value.
Thank you.
Yeah. So in those examples that I was showing here, all the usage of those secrets are tied to the make and things like that. So here we have an example of how you could use your secret in a run execution or in a pipeline that you don't have either a bash script or something like that. You could do, for example, a Docker login, passing the username, my username, which is being defined here, and my password, which is being defined here. So you can use those things in the execution of the step itself, but you just didn't see here, because if you see the make gh apply, you're going to have the environment variable passing through the compose and the Docker. So we try to do that because it's normally cleaner. You don't have all the let's say all the trash in this file, but you can do either way. And so what you have the pipeline, nice. You have all your steps, all your jobs, cool. And in order to see the execution itself, let's jump into and I'll show some actions in our own repo because it's easier, it's there. But you guys can see later, you just come into the action subsection here, and then you have all your workflows that you have defined in your .github/workflow folder. For example, the dashboard generation here, we can see when it was executed. So it was yesterday, it took 3 minutes and 10 seconds, was scheduled. And you can just get into here. You'll come to the specific execution of that actions, and then you have the steps here, right? So sorry, the job here, which is dashboard, and then you have all the steps defined. So this setup job is not something that you define. It's just setting up the job to be run. It's automatic. The first step here would be the checkout, which is an action that pretty much brings the code into the runner. So it has some steps here to just pretty much do something like a git clone and make sure that you have the latest code or the code related to that commit specifically. This is pretty much automated GitHub actions. And then we have the next step. And if you look into here, I think it's going to be nice to show. So code and GitHub workflows and the dashboard. So the first step is the actions. And then we have the second step, which is update dashboard sheet. And if you look into here, this is, yep. So update dashboard sheet. So it's the same name. And what is running is the make dashboard, which is defined here as the run make dashboard, right? So, and then you have all the logs, and that would depend on your make commands, your scripts. But in here we have a few Docker compose being executed and generating, checking which exercise was completed, which is in progress, and things like that. So it's a long script just to check for what has been delivered pretty much from you guys. And then it just updates worksheet in Google Sheets, and then generates the charts that you guys normally see on Monday and Fridays, uploads to S3, and publish that on Slack channel, right? So this is all automated, all through GitHub Actions. It has a few steps in this single step. Let's say even that in here, we have a single step, right? We have a single step to make the dashboard, which it does all those, create the, validates what has been delivered, generates the Google Sheet, generates the charts, and sends to Slack. Everything is being executed in this make dashboard. We could have different make executions here. It would work. It just doesn't make a lot of sense for us, but it could be changing in the future if you believe that needs to be segregated. But you can do whatever you want in those steps, right? There is no, as I said, there is no rule. There is nothing that constrains you from doing anything. It's just a matter of delivering what you need and improve it from there. Normally, you won't have a perfect pipeline right from the beginning. You're gonna have something that works, and then you're gonna do your change and making improvements as you go. And this is pretty much a DevOps mentality, right? It starts from what you need, deliver something, and then it starts improving and making things better, easier, and things like that. If, for example, we look into a different action here, for example, class labeler, it's something that runs on pretty much every pull request. Again, if you look here, it's called, oops, sorry guys. This is the class labeler, and let's say this one. Yes, class labeler. So just has a single step here again, which uses again a Docker GitHub action that is publicly available, and just need some kind of secret here. It would just label things based on a class pretty much. So if you look into, it has a file, this specific one has, in this folder, it has O labeler, which defines for which tag or which label will be added to the pull request based on which specific files, right? So, and there's a red review. So if you guys see all those labels when you guys create a pull request here, so pull request and all those labels here, they are automatically added. And if you look into here, we have all, you can see all the GitHub Actions workflows that were executed for this specific PR. So the class labeler, the content labeler, and the thing labeler, and all successful. And you can jump just here and see the details for this one. So this is the action being running, which runs the action labeler. Done. So it doesn't provide all the logs here because it's something that was designed to be this way by the developer that created this labeler and this action, but it could have all the sorry, all the logs, everything if they desire. And you can see all the other workflows that were executed for that specific pull request, right? The thing labeler and the labeler itself, the content labeler. Any questions on those and how to check those? Actually, it's pretty simple. It's not a lot about it in terms of checking. You're probably gonna have a lot of, not a lot, but if you see some issues during the execution, this is the best way to look for it. And if you don't see a lot of logs, you might need to add those logs into your own scripts and your own make files, just to understand what is happening, what is failing, and yeah. Any questions, guys?
Is there any way to test it before push to a master or submit a pull request?
That will depend. Let's say, for example, here, if we look into one of the workflows that we have, those that has a GitHub Actions that is being used, like those labelers, is not something that we can test because it only runs through the GitHub Actions, and it doesn't make a lot of sense. But if you say that, I'm changing some Terraform here in the plan, and I want to test that locally. So that's the purpose of the 3 Musketeers, right? So if you run make GH plan, and if you have those environment variables in your local, the result that you're gonna have from running on your local should be the same that you're gonna have when you push code here and execute it by the GitHub Actions, right? So,
Chico,
yes.
Well, just complementing what you're saying, and that's one of the main benefits of 3 Musketeers. Yep. So you want a dumb pipeline with some simple commands, so you can run it locally. If you change your CI tool, you can just write the stages or steps in this new tool. Yep. So it's pretty easy to read and understand when compared to other approaches and pipelines you'll see in your life.
Yep.
And besides that, it's possible to run GitHub Actions locally using a tool that I'll send in the chat.
Oh, nice.
You can even download the Docker image for the Ubuntu agent that it is using. As this agent has almost everything, I think the image is like 2 gig or more.
Yep.
But
I have to recreate that in GCP. Yeah, it's insane.
Yeah. So yeah, you can test it locally, but this is for just GitHub Actions. So don't count on it for other CI tools. Just keep it simple.
Yeah, and those actions is just a container pretty much, right? So that's why you can run on your local. I never tested, so I wasn't affirming that, but because they are containers, yeah, it makes sense to be able to run. But as Dennis said, it's not ideal to use or to have these as a thing that you rely on, because if you need to change from GitHub Actions and okay, now I need to execute my pipeline in BuildKite or in, I don't know, in GitLab CI/CD. If you have everything through 3 Musketeers, the migration will be really, really easy to do, and not a lot of effort will be required to migrate those things. And again, you can run everything local, test, and then push code, and the behavior should be the same. Does that answer your questions?
Yeah, okay. Just another question.
Sure.
Is there any way to, I think, if you allow a step or a build fail, I don't know if it's a good way, but if something didn't run properly, you allow that step fail and start to run another step.
I think it probably is possible. I would need to check here in the configs here, some kind of step behavior. I would say that it's possible. Most of the CI tools, they provide this capability. I would say that the GitHub Action should provide that as well, but I'm not 100% sure. I can check and provide that feedback.
Okay, that's fine. Thank you.
Hey, Kiko, do you have time for a tricky question?
Yeah.
So if you go back to the exercise example showing those 3 jobs running for the labels.
Yep.
So basically they are 3 different jobs running separate.
Yes.
How would you put them in parallel running?
Those are 3 workflows. They are not 3 different jobs. So if you see, here, I'm just going to the workflow. So each of these files here is a different workflow.
Okay.
And they will be executed based on the configuration that we have there, right? So those 3 are the content label, the label, and the theme label. And we should probably rename those to make things easier to understand. But each one of these is a different job and a different workflow. So that's why they normally run in parallel. And if you pull something right now, if you push something right now and create a pull request, you're going to see that the 3 of them will just execute in parallel.
Oh, okay. I thought they were waiting for the first one to execute and after.
No, because they are 3 different. We could have a single workflow here that will execute the 3 of them. We just didn't do that because those were progressively being added. So we just, in order to make things faster, we just added a new file and added a new new workflow. But we could have as a single, let's say, labeler and have the 3 jobs being executed in parallel as well. There is no dependency between them, so we could be doing that.
So if you add, so this one has the job called label. So if you add another job called label something else, those 2 will run in parallel already?
Yes, unless you define a dependency between, which is what we have. Let's come back to the class. I can't recall the instruction here right now. Yeah, you should be defining something as a dependency here. So actions. So needs build. So this means that in order to run the alert job, it needs build completed and completed successfully.
Understood. Thank you.
Any other questions, guys? There is nothing else from GitHub Actions. I hope it's clear enough so you guys can start to putting those workflows in your repositories and running Terraform code from an automation perspective, and also building the Docker image from the Docker file once we have changed there. But if there's no other questions, we can finish up here.
Okay, this is really cool.
Sharp 8:30.
Yeah.
Wow.
Just
not easy.
A quick reminder, guys. The project deadline is Sunday, not this one, the next one. It's not on Tuesday, so you expect to come up on the Monday before the next class. You won't have access to your project repositories anymore, so you can have some time to run your codes and get something to ask you guys during the presentations.
Cool. Thank you, 3 Musketeers.
3 Musketeers.
Run the poll, Dennis.
Sorry?
The poll.
The poll.
Oh, yeah. I always forget. Launch it. Yeah. So quick one, 2 minutes.
We got a PR in already to fix your permission on your repositories to use secrets and everything.
Along with that, after running, it might undo some of the changes you did in the project. I think some of you, let me check here, because we do Terraform plan in our CI. And I saw a project name, I think, was going to be removed.
That's not good.
Because now that you get the idea of Terraform and CI, right? By applying this permission change, we are restoring the project to the desired state in Terraform. And I don't think it had a project name or something like that. Let me check. So yeah, group 2, the repository project has, I think it's a name. No, it's the description. Migration to AWS using IAC. So it's going to be no. But apart of that, yeah. Of course, we can ignore changes in specific attributes as well, if you want to.
Oh, good. Next class, I think, is just presentations, right? Do we need any else? Do we have class? it's the kickoff of the next project and the presentations. Pretty sure.
There's some content plans, Kyle, but we need to discuss if we'll have time for that. It's the start of serverless, so I think API Gateway and Lambda. Yeah, serverless introduction, Lambda and API Gateway. And the kickoff of Project 2.
Okay.
So yeah, let's chat about that. We don't want to hold you for 5 hours here.
That's good. Well, thank you very much, guys. Yeah.
Right.
Nice, Bonita.
Thank you.
Good catch on the CloudWatch. Just
Yeah,
saw the message.
yeah, it's really useful. When you said when you are explaining about the log groups, I was going and checking it was not there, so I got it now. I didn't think ECS will fail because of CloudWatch.
The class already helped.
Yeah.
Yeah.
Thanks, guys. See you next class.
Yeah.
Cheers.
Thank you.
Thank you,
everyone.
Have a good night.
Cheers.
Thanks, everyone.
Thank you.
Bye-bye.
Stop recording.
Well remembered. Stop recording.